So I think, first of all, a big thank you for everyone for your interest in this subject. I obviously think it's a very important subject, but also I acknowledge that there is so much going on at the moment. So happy phase 2 to everyone. Hope you're staying safe. Happy GE to everyone. Despite my surname, I'm actually Singaporean. I was born here, lived my whole life here, failed my IBPT here, and although I did study overseas for a few years, Singapore is definitely home for me. So I'm looking forward to share on this subject with everyone. I'll just do a quick introduction of the company I work for, as well as my role there. So I work for a company called MSD, and it's one of the world's largest pharmaceutical companies. And I work in IT. So basically our job is to use technology to help enable our colleagues in research, manufacturing, and so on to bring our medicine to patients. And I will just share a bit of my own background. So I'm from left to right, I'm interested in kind of this Venn diagram. If you imagine people and AI, I'm interested in the intersection. And I'm from NUS School of Computing. But also I think I may have a bit of a less common background because I wanted to mix around my study a bit, and I was not able to find a course anywhere, so I went back to school a few times over my career. So I went back to school actually 3 or 4 times, and so I did four degrees, even though I'm not a PhD. But I think what I learned from that is that this whole area of responsible AI is very, very cross-functional. So no matter how broad I go, there's like so many aspects to it. There's legal, regulatory, technology, project management, product management, engineering. And so I encourage all of us to embrace this complex world that we live in and to work broadly across our organization, both in and outside of IT. On the bottom, it's great to hear everyone is interested in AI. Sometimes I do find that AI becomes a bit of a blanket term that does not have too much meaning, a bit more of a marketing term. But from a delivery perspective, depending on the kind of industry you work in, we have different parts of AI that we focus on. So for us, my teams, their lead is I have a language processing team, a computer vision team, an intelligent automation team. And I also have, I'm also one of Singapore's first full-time AI ethics professionals, which I'll talk about a little bit as well. I also confess that I'm a bit more of a writer than a speaker, so I'm afraid I don't think I can turn up my energy to band level, but I will try my best to, I guess, communicate something useful. But for those of you who prefer to read rather than listen, actually I write a lot, and I have accounts both on Medium and Quora. I recently stopped on Quora, but so I've started writing on Medium. And I think I have about 1,000 articles on the subject online. I want to start with data. Why am I here? Why are you here? What problem are we solving? At the start of this year, there is this global survey on, what's the level of trust people have in technology? And a few call outs here from left to right. 61% of respondents say that things are changing too fast. 66% of respondents are saying that I don't know whether what I'm seeing is real or not. And this was at the start of the year. With what has happened over the past half a year, maybe that percentage has increased. And the third one is that government does not understand emerging technologies enough to regulate them effectively, and this is at 61%. Also, a bit disappointingly, Singapore is one of the countries where this number is trending down. And I think all of us here on the call have a very important part to play because based on what we do in our respective working contexts, we can reverse this for the better. So also from the same survey, I think the way they were thinking about it is that, we want people who are ethical and people who are competent. And so they tried to map different groups like media and business and so on. And basically, we want to have this mix of both a strong capability and competency in delivery of AI projects, and also melding that with, ethical values and today we'll talk about how these two things can come together in a practical day-to-day work kind of way. Also, I think I want to just orientate us to what's going on in the space already from a Singapore perspective. So I think the first document that came out in Singapore was the first edition of the Model AI Governance Framework, first edition. This was at the start of last year. And I think as the different groups, IMDA, SCS, they went out to get feedback. Right now, we are in the second iteration, like version 2. And so firstly, we have 3 types of documents. One is an updated model of the framework. Second is a self-assessment guide, which it's more like here's a checklist of some tens or maybe over 100 questions to make this into something more implementable that you can check against. And thirdly, in terms of fleshing out what it means, here are also a compendium of use cases. My team actually contributed to one of these use cases, so you will find a use case on HR analytics from MSD here, and I'll also talk a little bit about it in the talk in a few minutes. So our roadmap for today comes in 3 parts, and the 3 parts are not the same length. So firstly, I acknowledge that, I've sat in your position before, and it's very hard to sit here for like 40 minutes, 45 minutes to listen to someone on Zoom. So if you need to drift away for a bit and come back, the way I'll be doing it is I have these 5 points. The first point is framing the AI problem and responsible AI landscape, giving you an overview of what's going on in the space. Secondly, we do 3 deep dives, 1 deep dive each into data, algorithms, and like recommendation engines, which is a common AI project. And thirdly, I'll do a bit of here's a process that you can kind of think about. So I have like 5 parts, and each part is supposed to be about like kind of 8 minutes, 8 to 10 minutes. And so if you find that you know one part very well, feel free to drift out and come back in. So I think that's the way I'm going to structure today. So going straight into the first one. Oh, one other thing. Sometimes, I may have to talk in a bit of an abstract manner because due to like compliance requirements, I can't like kind of speak exactly at the level of what we're doing internally. But I'll try my best to mix the concepts with actual things you can kind of take hold of and kind of bring home and use. So whenever you see a slide with this sticker here, implementation, that's something that, maybe I can relate that to something I'm doing today and just do it, take that home in a practical way. So jumping to the first one, I think while I may be working in AI for a while, I think many people here are much more proficient and skilled and experienced as project managers. So I want us to have this mental journey together, And I want us to think of this question: what makes an AI project different from a typical IT project? And I want us to think of this question: how accurately can you predict a person's age from the person's photo? Have to think about this, right? And this is relevant because many AI projects are exactly like this. How can I predict X from Y? How can I predict whether someone will buy something based on their browsing history? How can I predict what my sales will be based on previous inventory levels? And this pattern is a very, this pattern has something special in it. And it's this. Do you know whether this is even possible? Do you know if this is even feasible? Do you know what's the right technique to use before you commit it to a plan? And do you know there's enough information in the data for the results to be useful enough in a real world setting? If, for instance, I'm able to only predict to like 10 years, is that useful enough? If it has to do with does it change if it is someone from a different country trying to predict a person's age from a different like ethnic group? All these things come around this idea of uncertainty that does not exist in a normal like IT project. If I'm upgrading a version of software, if I'm building an application, you don't have this idea of uncertainty in the data, and you're not even sure whether it'll be useful until you try. And so because of this, it's very important to structure AI projects to make sure it's feasible before we commit to a larger long-term implementation. So instead of like, upfront 6 months and 5 people, you might want to do, let's do 4 weeks with a data scientist first, a POC, and to see whether the project is feasible based on the data before we do a longer term project. So there are some statistics going around that 80% of projects fail and so on. But I think in my view, this is just the science part of AI, where we need to deal with uncertainty by experimentation, and we want to de-risk a large implementation based on a small POC. So I think it's perfectly fine that 80% of POCs fail, because it's better to fail with 1 person on 4 weeks rather than 5 people on 6 months. Yeah. And just to also give you a sense of what technology looks like today, this is, I think what I understand is state of the art in terms of machine learning for age detection. And on the left, you'll see George Clooney. On the right, it's just a selfie photo. And people may not know what goes on, what technique is the best to figure out someone's age. But as it turns out, state of the art is like looking specifically at the eye. So I can ignore the entire face, but if I know the square around your eye, I can predict a person's age to about 2.3 years. And again, this is an example of we won't know what's the right way to go about doing this until we try. This is not like a software application where I can plan my front end, my back end, and so on. This is something that, should I try the hair, the face, the eyes, the nose, the mouth, the angle? And so there is this idea of experimentation, deal with data uncertainty in AI projects. I think this will be the first thing I want us to take away. Second, I think also from a practical point of view, often we have AI wrapped up with data, analytics, machine learning, data science, AI. And so how do we unpack that a little bit? To orientate you to this diagram, I will give you maybe a quick example. I want us to think about our GPS in our cars. So I think traditional analytics is a lot about helping people to make decisions. Yeah. So a GPS is just like that. It helps us to make decisions. Whether I use a dashboard, which is descriptive, or whether I do forecasting, which is predictive, or optimization, which is prescriptive, all these are tools that helps a human make a decision. But the distinction of AI projects is that some AI projects go beyond that to executing on your behalf and making decisions on your behalf. A GPS is a tool, but a self-driving car drives for you. So I think I want to just step back a bit from all the buzzwords and keywords and realize that it is really about autonomous decision making. That you have a software system that's doing things on your behalf, of which you might be liable with, and that is like one big part of the problem. So we've gone from a tool to a worker. It's not to say that all AI projects like this, and in fact, the vast majority of AI projects are augmentation rather than doing it on your behalf, rather than automation. But nonetheless, I think this is a very useful way to think about it. So in summary, for my first 10-minute chunk, 2 things to take away from a project and product management perspective is that data uncertainty and autonomous decision-making are at the heart of many of these issues. And we don't face this in other types of IT projects because in these other projects, we don't have these 2 elements in play. So with that, also, I'll say that, you might hear all sorts of things on what AI ethics, responsible AI might mean. I think here's a way to think about it as well. It depends on who you are talking to. If you are like a technical team, like technical delivery, like our team, we are really on the far left-hand side of the problem. We're thinking about, is there a bias in the data? Should I build something with my algorithm and so on? Coming a bit further to the right, you have kind of like whole team, whole company issues, things like policy, fairness, governance, and so on. Yet further, we have these like kind of national level issues. So lots of the things that if you look at the PDPC and the IMDA website and so on, you find that these are regulatory questions that we are starting to think about, as well as things like a liability in IP. And over, if you are following people like Elon Musk or Jan Tallinn and people like that, you find that they're thinking about long-term effects of AI. So and all the way on the right, you have this whole bunch of things that maybe don't fit so nicely, but are kind of weaving their way into our human life as well, which are issues that cut across multiple ones of these groups. So I think this is very much a work in progress, but just to give us a sense of, I guess, a distribution of issues at a different level. And our deep dives will basically address like 3 chunks of this, not everything, but to give us a taste of how different parts of this framework look like in practice. All right, so I'll jump to the first section, and this is around data. And I think AI and data is very much intertwined, because AI systems are often limited or only as good as their data. But also there's lots of frustration in why are companies like using data without me knowing, and the company will come back and say, oh, but we did tell you because you take, I agree. And this is actually an art piece called I Agree, where this artist basically tried to print out all the terms and conditions from the different social media platforms. I believe the one on the far right is, I think it's Instagram, and it took close to 1.5 hours to read. But so this is not a very good state of affairs, but I guess in a sense, there is that legality to it, but it's not a very good state of affairs. But however good or bad that current state is, right? What's happening today is that we have smart cameras. So we don't even have that chance to read our how many pages of content to agree, because simply by walking down the street, walking down a corridor, your data might have been taken. And so I don't have the knowledge that I'm giving consent. So you have this whole idea of consent breaking down. And there might be some legal professionals on this call. So I'm not a lawyer. And I think I'm coming in from a bit more of like technology product perspective. So yeah, just to caveat, I'm not an expert in this space. But what I do see is that there are like a few ways that we can mitigate these things. The first one, which I will not cover, is if people don't have the ability to give explicit consent, we can have this discussion around what is a legitimate purpose. Like if, for instance, I'm doing contact tracing to protect the health of the population, maybe that's a more legitimate purpose than taking your data and sending it to a third party without your consent. But I will be giving examples on the second one, which is like if people on this call, we are put into these projects where we have to manage computer vision type implementations, how can we think of some of the issues there? And the third one is if we are building apps, how can we think about data protection by design? So this is a computer vision one, and I think many of us would have familiarity with Trace Together, right? Because in Trace Together, what we have is we have these Bluetooth signals that do not collect individual data by design, but yet there is this discomfort with it. So many people are like very suspicious of Trace Together, and so it's a very difficult position, because even when we are doing the right thing technically, there is this suspicion on whether or not understanding what's going on, and this might be even more so when we start thinking about video type AI projects. So these are, again, work in progress, some things that we are trying out. The first thing is at the architecture level, what we transfer is important. People are very concerned if we transfer personally identifiable information. So if we have like a security camera taking a picture of us, and that picture is transferred, we have cybersecurity issues, or people coming in to hack through and get the feed and things like that. So having the edge/fog architecture, where we actually do all the processing on the camera or near the camera itself, and then only transferring data that is not identifiable. That's one example. The second is the actual processing itself. What we want to do is we want to get the benefit of AI systems, but also preserving the privacy of the individual. And so there are many technical ways we can do it. I'll just give you one example here of a very, very basic project that uses cameras to do like people counting. So a very basic computer vision application that counts the number of people in an office based on how many people exit the room and enter the room. And so when we were quite transparent about trialing this project, but people were telling us, we are so concerned about privacy and so on. So what we did to alleviate the problem was actually to show them what our computer vision algorithm was actually seeing, which is the picture on the right. So I'll play it again, just like a couple of seconds. And so as you can see that, we process it so that only blobs are seen, and it will not be possible to figure out the identity of the blobs. It's just one technique, and there are many, many techniques similar to this, but this is just a basic one to show that, one way we try to engender trust is to show people what exactly goes on in the algorithm, so they're convinced that it's not identifiable. So it's a bit of a show rather than tell kind of approach. Coming over to apps, this is an example of, I guess, exercise we did together with a couple of technology companies and IMD as well. So this is not a real app, but this is trying to reimagine like ride sharing kind of apps or like location apps and so on. So I want you to think about if you use Foodpanda, Deliveroo, Grab, Gojek. When we click the location, right now, you might have some like consent where they say, we want to have your permission to get all your data and so on. And think about that whole experience. They're asking for all your data up front, right? Maybe there is an alternative to that, such that only when you're making that individual transaction, maybe I'm only like ordering like one bowl of porridge one time. So I only want to give my location for the next half an hour today, instead of all my data forever, right? So that's the first kind of approach that we can do. And the second one is about, in this app, it's like, to show you the best concerts, tell us where you are. And instead of tracking my GPS, instead of like, getting the live feed of our data exhaust, maybe change it into a form. Let me just tell you, let me give you my snapshot instead of giving you my feed, right? So, and let me limit the purpose for it as well. So it was a very interesting exercise that we went through. And I think the thing that was most telling from this exercise is that we couldn't think of any company that was doing this at the moment. So I think there's a point of view where right now everyone is thinking, oh, data is the future, is so valuable, and that is true. But perhaps we could also flip it around and say, well, are we competing on data, or should we compete on trust based on deliberately limiting the data that we use? I think that's a very interesting strategy as well. It's actually not for like a teams like ours to lead. This is really like kind of a program lead kind of decision, a product lead kind of decision. And often we're like one step removed. But I think for those of us here who are in those positions, something for you to consider. So that is a deep dive number 2. So deep dive number 1. Second, I'll talk about algorithms, and this is about the discrimination bias kind of a question. Usually, if we were in the same room, I would try to pick on someone who's playing their phone and say, why don't you put CEO into your phone at the moment, into Google image search, and see what comes up. So This is what came up when I did this exercise some time ago. And as you can see, it's predominantly a certain demographic, older, whiter male. And this was particularly offensive because of the few female representations. There happened to be one Barbie in the bottom right-hand corner as well. So that was like its own issue. But you know, some of these things are annoying and offensive, but let me also quantify it for you. There was this paper which I read where they said that if you are female and I want you to imagine a Google search, right? On Google search, on the right-hand side, when you search, there are these like advertising in yellow boxes coming up for you. If you are female, they put side by side and they did a test, a statistical test. And a female and a male both put a high-paying job like CFO or CEO into Google search. Systematically, if you are female, the yellow advertising jobs that are shown to you pay less, statistically significantly less than if you are a male. So what's happening is algorithms, without knowing what they do, without knowing what's going on, they are systematizing the bias based on like past data by, you know, just the way that the algorithms learn. And so this is something that people are becoming increasingly aware of and something we might want to lean against. But it's also not so simple. I'll do a quick run through of a small case study to illustrate. I'll be using basically the framework of the Model AI Governance Framework. So for those of us who are interested in adopting it, I will, you can look on the right-hand side of the next few slides, and I'll basically be marking off certain parts of the framework as I apply them. So the example that I'm thinking of is basically a HR kind of example. So can I predict high performance? Can I predict a certain kind of trait in HR? And so the first question is, you know, when I implement this from a process level, do I want a human in a loop or not? And when you look at the framework, you can see, you can read all the text for yourself. But if I can make it simple, it really has to do with what happens if you make a mistake. If the algorithm makes a mistake and it's not very harmful, then you might consider a human out of the loop or human over the loop. Over the loop, that means that a human being doesn't check everyone, but maybe he doesn't audit once in a while. But if the probability of, if the impact of a mistake is high, then you want a human in the loop, definitely. For instance, if you are, say, doing a chatbot kind of project, and the chatbot is not very smart and gives the wrong answer, well, the person gets a little bit annoyed, but then maybe he'll pick up the phone and call if it's like a restaurant or something. So that's really high probability of mistake, but low severity. You don't need a human being to check every single transaction between a customer and a chatbot, but you might want to audit your model once in a while. So that'll be human over the loop. But when you're talking about things like assessment, hiring, talent, these things are like career affecting things. You definitely do not want to do anything automated there, and you want a human in the loop. And in general, if you're in doubt, a human in the loop would be a good default to go to. The second thing is we hear bias, and data layer data, but this is really a map for you to take back based on a paper, a really good paper that only came out last year on where this bias actually exists. And in practice, when I look at our own projects, I would say that it's very, very hard. I would say it's maybe impossible to eliminate bias, but we can identify and mitigate it to some extent. I'll give you two examples. Think about, say, a second one called representation bias. Let's say that I do a trace together survey online. Inherent to that is very likely representation bias, because maybe people who are less likely to check in using trace together versus using the NRIC, probably maybe the older generation might be underrepresented because they prefer to use NRIC. So So that's one example of representation bias. The second one is, let's look at evaluation bias, which is the one at the bottom. Let's say that, I want a model to be really accurate, 95% accurate. Is it possible? 95% accurate. There was this researcher in MIT called Joy Bulawami, and he found that some of these facial, like this demographic recognition AI systems who were 95% accurate were actually 99% accurate on Caucasians and 60-something% accurate on like black, like people with like dark skin. So I think the method used to evaluate, instead of having a single metric, sometimes you want to do it, okay, let's do it by different population subsegments to make sure that it's not a case of one part being very accurate and one part being having lots of mistakes. And we'll see towards the end of the presentation, like one quick example if we have time. The third issue is fairness. And I think I want to also bring across the complexity of making something fair. Because when we think about fairness, what comes to our mind? Some people think equal outcome, some people think equal opportunity. But if you really want to code it into an algorithm, research shows there are at least 20+ different definitions of fairness. So let me not be too abstract and let me give an example. Let's say that you are, so by the way, don't this is a very dangerous use case, so don't do it, just for example. Imagine if you had an AI system to vet the candidates because you have too many candidates coming in. And just so happens that it is a function like manufacturing or engineering where there are historically more males than females, are very common. What does fairness look like here? Does it mean that if from top to bottom, if I have 16 applicants and more men than women, does it mean that, okay, since there are more male than female, I'll take the equal proportion of males, the equal proportion of females? That's one example. Maybe that's fair. Secondly, second row, maybe I want to totally be gender blind and say, okay, do not tell me the gender, and I will just see who's qualified and take that meritocracy. Maybe that is fair. Or you can think that, oh, actually from a population level, it's like I have half and half. So I need to to move towards population parity. So I try to do like maybe half men and half women. All these are defensible. All these are academically correct, but they are, as you can see, in conflict with one another. So these are difficult questions that it's not really an IT question that you can, hey, data scientist, please make my algorithm fair. That person, he or she, will come back to you and say, okay, which of the 20 definitions of fairness are you talking about? So it is a tricky space, and so something to think about. In practice, we had this conversation with like our kind of lead, HR leader, and we had a human in the loop, and we made sure that it was not autonomous, and we had discussions on understanding what were the drivers of each individual, and it became quite a rich discussion. But if we were to just close our eyes and say, okay, predict and give me the list, all these issues come into play. Yeah. Also, I want to give some like practical measures you can use if you are new to leading an analytics team. So when you look at data, often it's just like many columns of a database or spreadsheet or something like that. But there's a difference between demographic versus behavioral data. And often it's, you need to think about the basis of the decision. So for instance, if I have, using the same use case as just now, I'm looking at HR data, I'm looking at everyone's CVs and history and skills. If I hire someone on the basis that they have the right experience, they have the right skills, they have evidence of industry domain knowledge, That's very different from the algorithm saying, oh, I hire you because you happen to have a certain ethnic group or happen to be married or single or something that's demographic in nature. So to an algorithm, columns on a database are just columns in a database. But from a human's perspective, when someone has, we want to make our decision on the basis of proper, valid decision characteristics that are often behavioral and lean away from things that are demographic, because that's where the kind of discrimination comes in. So again, it is not so straightforward, because sometimes if I don't know for instance, I don't know your gender, but I know your number of days of maternity leave. So I can kind of predict your gender and all that. So you might have to add proxies. So not just the demographic data, but also I might have to remove data that are proxies to demographic data. So it's not so straightforward, but I think it's a good starting point to think about data that we use. I just want to talk quickly about black box models, and this is a term that I think I see being used increasingly. And again, you can Google definitions, but in a simplistic way, it's like, this algorithm has made a decision on my behalf, and I don't know why he made the decision. So can the algorithm express the rationale for the decision in a way that I as a human being can understand? So that's basically the conversation we're having. And you hear terms like, I want to go from the black box, which is opaque, to the glass box, which is transparent. And we'll talk about that in our next slide. From a delivery perspective, there's actually like, I see it as like three distinct parts. One is, the actual model itself, right? If you think there's a need for a user to understand why the algorithm made a decision, then you need to invest in like a technical explainability modeling. So don't just like train a model and deploy a model. Also, add in some maybe effort and budget for, okay, besides just training and deploying the model, also add some investment for making some features so that the model can express what is driving the model. The second part is interpretability. Just because someone programs something in doesn't mean the user understands how to interpret some of the complex ways a model is starting to express itself. So if you're doing UAT, you're doing testing, don't just test the functions, also test whether the user understands the explainability that the model is trying to express. And thirdly, from an organizational perspective, even if your project is interpretable, also you need to engage with the organizational layer where you might have policy around, okay, I will, on my website, I'll tell you what I do with your data in a simplistic way that people can understand. I will tell my users when I'm using an AI system to engage with them and all these things. And that's kind of that top layer where we want to not just work within a project or product, but also we need the organizational alignment as well. I'll go to maybe not too much detail here, but I think two broad strategies to make our predictive models explainable is either on the left, I choose a simpler model. So maybe I go from something like deep learning to something like logistic regression or decision tree. Or the right is I can use my deep learning model, but then I also implement an explainability method on top. So both ways, you get human understanding, and the trade-off is different. On the left, I lose some of my predictive power. On the right, I need extra development effort. But both ways are strategies you can adopt. Also, when I want you to consider what kind of questions you ask a machine learning model. I don't have like children or family, but I think I recall a discussion around PSLE, and imagine you want to know how PSLE students was assigned to schools, right? And I want you to imagine what the question might be like. On the far left, it could be, hey, the model put you in this school on the basis of your grades, your CCA, and whether you have alumni from your family in the school. So that's like, how does this model work? That's question one. Number two is, is there a possible bias against a segment? Why is it the case that everyone who live in this district or everyone with this ethnic group, was there some strange pattern in the model that people with a certain demographic are constantly miss out on this school? So that's something I want to check against. And the third one is at some level, right? The user is just like, okay, don't tell me all these kind of model things. Just I want to know for me, why did you classify me in this way? And then the model must say not this high level, oh, it's because of CCA and because of grades, but it would be at the individual role level. Or this particular person got in because maybe it is through sports or through something that is unique to the individual. So I think mainly I want to make a distinction between a high level, this is the way the model works, and a low level, this is the way that particular role was predicted against. This may seem a bit nuanced, but what's happening in the world is that, especially in Europe, people are starting to have the right to question and the workings of individual algorithms that affect them, as well as ask for a second opinion from a human being. So I think this is trying to get ahead of the regulation before it comes over to Asia. And so just to think about these two levels of explainability. And finally, I want to end off with just like a cultural question for us to think. So when we implement these things like step by step, like, okay, we just implement, but then once all the pieces come together, it's actually like something else appeared for me. And so we put these steps in. Firstly, okay, now we know that because the human in a loop, we have someone who's responsible for this decision. Secondly, because we're auditing all these things, we have all this evidence that is now in the organization. And thirdly, if there's a bias, we even have a driver on what the machine thinks versus what the human being thinks, and all these drivers of fairness and all these things. And so what happens is we end up having quite a lot of difficult conversations. So I think my first point when I started this was, this is quite cross-disciplinary, and it's a really interface of technology with business, compliance, ethics, and all these things as well. So do be prepared as you enter this space that there might be a case of some uncomfortable conversations they're often like overdue, but need to happen as we implement AI. So there's a big irony that, it takes an automated system to put us in our human way of making decisions and to force us to talk about these things. So I'm conscious of time, so I will actually skip over this part a little bit and jump straight to the last section, which is on a bit of a process that we could use. So bring it together, I want to put a snapshot of all these things I've talked about in a bit of a slide. And I won't go straight point by point, but I think this deck will be made available. So feel free to listen to what I said again and map it to what is on this slide here. But to bring it home, I want to actually bring it to an example that happened today. So this morning I got up and then on my newsfeed on New York Times, this was on the front page. So this person was wrongfully accused by an algorithm. So a bunch of policemen came to his house, arrested him in front of his wife and children, brought him to the lockup and then showed him a photo. And it turns out in the photo, an algorithm was used to spot him as stealing a number of watches. But once you look at the photo and you look at him, it's clearly a different person. So this is first of its kind, very timely today. And I want to test this system, like this scenario against what we just talked about. And so, how could we fix this? Have a human in the loop, number two, build transparency, explainability in the solution, check for bias, and also over time, as your model evolves, these things will be picked up during monitoring. So not a perfect system that we are trying to develop here, but I think if we start putting these principles into place, instances like what we read this morning would not happen. So I will skip this, except to say that I do have a role in responsible AI, and the role is a mix of three things. I'll just go to the next slide. I think I found something very useful is that imagine if you're doing a transformation to AI, having someone that's able to bridge three parts, which is one is like the policy level, one is the corporate level, and one is the programming level. I found this person to be very valuable. So someone who's able to work from kind of like SOP policy down to like coding. This is something that I found very useful, and if you are on this similar journey, happy to engage with you more on this offline. So in summary, all these ethics and governance things is not something that I can just buy. So if I buy, all I get is the explainability layer, but I need to put all these things implementation-wise around it as well. Secondly, AI systems learn from the past and optimize towards the future. So the piece from delivery program perspective is like, we need to think carefully about the kind of world we want to optimize for. And thirdly, we're actually quite early in the story. And so those of us on the call, we can actually shape this to a large extent. It's not like everything is set in stone. Nations are figuring things out, governments are figuring things out, companies are figuring things out. And so thank you very much for taking this time to learn about this, and hope that all of us would be part of, I think, one of the big issues that is of our time. Thank you.